Just
There we are. Now,
actually, hold on. Good morning, everyone. Jomo Stewart here at the Fairbanks Economic Development Corporation. We're here for a special meeting, special engagement. Of course, we all usually meet on Tuesdays at 8 a.m. But to accommodate a guest, we are here again. It's Thursday, November 17th at 10 o'clock in the a.m. and we are commencing our Energy for All Alaska Task Force meeting. And I will hand it over. We have some special guests here. I will hand it over to one of those special guests, Mayor Welch, to make further introductions.
thank you, Jomo. I'm Mike Welch. I'm the mayor of the city of North Holde. And for the last 2 years and 2 weeks, I've been involved in a syngas team. And our project manager is here at the table, and that is Brent. Hello, Brent. And he's been involved in somehow I got involved in this. And I think best I know, I'm the only elected official that's involved in this project. And people that are here with me today, before we get to the top honored guest, I have Danny Wallace, my director of city services here. And then I'll have Mayor Josh Verhagen from the city of Nenana. He's going to probably have a stake in this game. And I know you're not the president, but what are you called? Honorary member of the North Pole Community Chamber of Commerce, Howard Ritchie.
I'm just a director. So.
Just a director, only a director. He's with us. And Will Staff just recently elected there. Tell us which district you're from.
House District 32, East Fairbanks and Badger Road.
Badger Road. So you'll have an interest in this. And Glenn Brady. And
Greetings.
tell us your name of your company.
Glenn Brady with Alaska LLC, with some other local businesses as well, but we're a startup building panel manufacturing entity.
Yes, and I think he will probably be with us at some point.
Yep.
As a customer using some of what we'll have in combined heat power. Ma'am, tell us your name and your position, how long you've been with ITU.
My name is Elena Seta. I am the Director of Public Relations at IGU.
Yeah.
Been there for about 2 years now.
Yes, 2 years. Thank you. And our most honored guest that came to us from Olympia, Washington. And he really has impressed us the last 2 days with even what Nenana has, what they're doing. He knows this whole thing. And I call him Dr. David Van Holde here from the Pacific Northwest Department of Energy area under contract with them. And David, I'll let you tell us who you are. Go ahead. Thank you, sir.
Yeah, all right. Well, thanks, Mike. Yeah, I'm Dave Van Holde. I'm not a doctor, but I am an energy expert. I think I can actually say that with some impunity at 65 years of age. I don't pretend to know everything, but I do know a few things. And one of the things I do know something about is combined heat and power. And that's really what I'm here to talk about today. So I don't know all the audience, and I don't think we're going to do introductions all around, are we?
We just did this room.
Yeah, okay, the room. But I welcome your input and feedback and our questions. Probably we'll move through this and then we'll get to questions. This is not a super detailed analysis or presentation on that. So it's not an engineering level analysis. It's really what we would call techno-economic feasibility. What I do, just to give you a picture, is I work for Washington State University, and we have had a contract for many years, some probably close on 16 years, with the U.S. Department of Energy, delivering both information and technical analysis on combined heat and power, which is also known to many of you as cogeneration. We provide unbiased analysis and information. So we don't have a stake in the game. That's important when you're walking into a project like this, where you might have parties that want to sell you something. We're not here to sell you anything. So we're here just to talk to you and help you think about this process together. So again, I have no interest in this project in particular, except that it appears to have the indicators that we look for a project. What else do I want to say? I guess I think I'm going to jump in first. And first I'll say, you're going to see a couple slides replicated because we're going to start with a presentation that Brent Sheets, thank you, recently gave to I want to say I think of it as a coal conference, but it's a big conference in Pittsburgh or Cincinnati on coal recently. And he was talking about the work he did for US DOE as well, under National Energy Technology Labs on some of the underlying technology and this project in general. So you're going to see some slides replicated, and basically what I did is I came in relatively late at these folks' invitation to provide third-party review of this in its feasibility, its analysis process. Is that a pretty good introduction?
Oh, very.
Okay, so.
There's Clay Walker just joined us. He's the borough mayor of Denali Borough.
Thank you, Mayor.
Was this easy to find here?
Yeah, it's just easy to find, but roads are a little icy and
Yeah.
it's like over 2.5 hours.
So I'm going to go ahead and play this. I think this presentation will present itself, and I'll let Brent speak in when he wants to, and we'll hope that'll all go.
My name is Brent Sheets, and I'm a research faculty member at the University of Alaska Fairbanks. And I'm here to tell you about our project, making coal relevant for small-scale applications. This material is based on work supported by the U.S. Department of Energy under award number FE0031601, and I wish to express my sincere appreciation and thankfulness for their support. In addition to funding our work, we have benefited from some in-house modeling efforts provided by NETL. Fairbanks is a medium-sized city in central Alaska, a region known for its extreme temperatures and rich history of gold mining. In the summer, temperatures can reach a sweltering 90 degrees Fahrenheit, and in the winter, they can drop to a finger-numbing 40 below zero. Fairbanks serves as a gateway to villages throughout the interior region of Alaska. Alaska is about 20% of the landmass of the lower 48, and believe it or not, we have more coastline than the lower 48. We also have 50% of the nation's coal resources. We have a dedicated team that has been working on this project since 2018, and for some of our team members, Rolf Maurer of HMI and Harvey Goldstein of Worley in particular, the timeline goes back significantly earlier. Suffice it to say, I think we have a great team of professionals, and I dare say they are all world-class engineers. This study documents the technical and cost evaluation of a small modular gasifier system producing clean syngas for firing and reciprocating spark ignition engines. The gasification process also produces a significant amount of pyrolysis liquids suitable for firing in a conventional heavy-duty diesel engine, or as is contemplated in our case, sold as a constituent for use in asphalt binders. Heat will be recovered and utilized in a district heat system. In March 2019, we completed a FEED study, also funded by the Department of Energy, to repurpose the older portion of UAF's power plant to host the gasification demonstration project. After some changes in management, the site is no longer available. Our new site is the city of North Pole, and frankly, it's a much better fit. The goal of this project was to revise our original 2019 FEED study to reflect this new site. If we can secure the construction funding, then the CHP plant will be built on the site of a former refinery within the city of North Pole, where the heat and power can be sold to its current site occupant, Marathon Petroleum, which operates the fuel depot on the site. It can also be sold to the city of North Pole, and we have many other customers, including a proposed 20-acre. Can you pause there?
Yeah, I think so. Pause. Oops. This is a big flag. Yeah. That's stop it.
Just check one thing.
What do you want to do?
Well, this is plugged in, but the volume's low. I think that's just because it's.
You gotta change this. Yeah, there you go. So now I think we give it a try.
That's Facebook.
Can't hear.
You probably have changed the volume output on the computer, bottom right.
He did.
I have.
Okay.
We're just trying to figure out how to start it.
Yeah.
Just click.
Is it not running? Oh, I think I need to hit that.
No, that's the animation with him.
So do we really need this?
Actually, it's fine. Y'all were complaining. Let's just proceed.
Okay, no.
Sorry, guys.
HMI is responsible for the design of the gasifier. The HMI gasifier is a derivative of the historical Raman and Volusia gasifier that has a commercial history dating back at least 80 years. HMI has built 2 other gasification units and has an application history utilizing low-rate fuels, including lignite, subbituminous, and biomix. The HMI gasifier is used in the Sotocarbo Research Facility, a research facility in Sardinia, Italy. Sotocarbo's HMI unit is a 4-foot inside diameter unit. For our project, the HMI unit is sized at an internal diameter of 10 feet. Experience gained by Sotocarbo provided important data and insight that were incorporated into our study. A simplified schematic of our system design is shown in this block diagram. With the exception of the gasifier, all components are commercially available. The gasifier systems and gas cleanup equipment was designed to supply clean syngas to 6 Janbacher engines. Several key technologies have been associated with the HMI gasifier system for over a decade. For example, the Bellini wet ESP plays a vital role in collecting tars and oils formed during the gasification process. These pyrolysis liquids can be used as a fuel for diesel engines and possibly other applications. But in our case, the tars and oils will be sold to a local customer for use as an asphalt binder. A caustic scrubber is employed following the wet ESP to remove sulfur-bearing gases. The clean syngas is then fed into the Janbacher GMS 620 engines selected for this application because of their ability to utilize low BTU gaseous fuels. After review of available options, the project team selected a design configuration using 8 Janbacher GMS 620 engines. 6 engines will operate on syngas and are rated at about 2,000 kilowatts each. Using the lower heating value, the electric generating efficiency of the syngas engines is 34.5%. After removing oil and tars from the calculation, then the electrical efficiency based on the heating value of the coal input less the heating value of the co-produced oils and tars drops to 28%. The overall cogeneration efficiency based on the heating value of the coal input less the heating value of the co-produced oils and tars is at 74%. The 2 natural gas-fired engines are rated at just over 3,000 kilowatts each. With respect to 2 engines fueled by natural gas, the electric generating efficiency of the Janbacher engines is 43.4%. The overall cogenerating efficiency of the natural gas-fired units is at 94%. Dividing the capacity of the system to generate heat and power yields $1 per unit of energy. Both electricity and heat are products to be sold. We have assigned 40% of the total costs to the production of heat and 60% of the total costs to the production of electricity in order to calculate a cost per unit of energy. Living in Fairbanks, as I do, and noting that winter is quickly approaching, my eye is immediately drawn to the cost of heat, and I see that my costs would be significantly higher if I were to pay $327 per MMBTU when I could purchase the same heat from the local natural gas utility for $22.84 an MMBTU. However, if I focus on the last row of the table, specifically the row entitled Heat and Power Combined, then I quickly come to the realization that I could be buying my electricity and receive my heat for free. This would happen if I were paying about 24 cents a kilowatt hour, or shown here is $239.73 per megawatt hour, and receive my heat for free, as I said. For the record, my current electrical rate is 27 cents a kilowatt hour, whereas I assume most of you are paying closer to 12 cents a kilowatt hour, or half of what we pay in Fairbanks. The lesson here is that since we are selling both heat and power, we can offer our customers a package deal. If they use more electricity, then we can give them a break on the price of heat, or vice versa. All 8 Janbacher engines will be equipped with heat recovery units for supplying a low temperature district heat loop and a high temperature district heat loop. The heat recovery units provide an important function by reducing the exhaust gas temperatures to provide a zone in the gas path of 700 degrees F for the catalyst beds. This temperature provides a good compromise for reducing CO and NOx while avoiding the conversion of SO2 into SO3, which can create other issues such as corrosion. The low temperature fluid is at about 124 F and will be used to heat the power building. The high temperature loop is at about 204 degrees F and will be supplying our paying customers. In addition, the Marathon Fuel Depot is using glycol heaters of substantial capacity. If the gasification project moves into operational status, then Marathon's units will be retrofitted to utilize heat from the high temperature loop. In addition to the glycol heaters, Marathon has available 2 large outdoor tanks, each with a capacity of 500,000 gallons of liquid The current plan is to refurbish these tanks, add insulation, and connect them to the high temperature loop to serve as thermal storage. Alaska imports about 95% of its food. Greenhouses today have the ability to simultaneously increase the viability of their crops and effectively control CO2 emissions. But because of Alaska's high cost of energy, it remains more economical to continue importing food into the state than it is to build greenhouses to grow our own food. Jan-Bacher has a standard greenhouse package. Their engines can provide heat, electricity, and CO2 fertilization, increasing a greenhouse's total efficiency, profitability, and plant production. Today, there are more than 1,500 Jan-Bacher cogeneration units with CO2 fertilization installed around the world, providing about 3,300 megawatts of power. Air pollutants would be emitted during the operation of the facility, including direct emissions of PM 2.5 and its precursors within an EPA-designated serious non-attainment area for PM 2.5. Our project design includes several air pollution control devices to mitigate ambient air impacts. We looked at different size syngas engine plants for deployment around Alaska in terms of efficiency and capital costs per kilowatt. The red line represents our design base using the Jan-Bacher engines. These plants are easily scalable in 2 megawatt increments, since that's roughly the output per engine. So our friends at Worley looked at 3 or 4 different plant sizes and created these curves. The blue line represents a circulating fluidized bed, or CFB, similar to the design recently installed at the University of Alaska Fairbanks power plant and hooked into a conventional boiler and steam generator. Obviously, you get higher efficiency with larger sized plants. But as you can see with our design, plant efficiency remains constant. In terms of capital costs, our design is also more budget friendly for the smaller sized plants than is a CFP. And this appears to remain true until you get to about 50 megawatts in size, in which case you're better off with the CFB boiler steam generator. We believe small-scale modular coal gasification to be a potential solution for meeting the energy needs of many of the remote communities of Alaska and potentially for the developing world. At least 193 of Alaska's remote villages, with a combined population of just over 81,000, rely on diesel generation as the prime generating fuel. And many of those communities receive only 1 or 2 barge loads of fuel annually in the summertime when the rivers are ice-free. The fuel is then stored in bulk tanks along the rivers. Those villages also have the highest electrical prices in the nation, 2 to 5 times the cost of electricity in Fairbanks. There are more than 35 remote communities with coal nearby, none of which utilize it as a fuel. A local source of energy could provide jobs in communities where jobs are scarce and provide a level of protection from price swings for diesel. But scales of economies necessary for making coal acceptable have traditionally hampered coal utilization on a small scale. If communities choose not to mine their local coal, then they can have it delivered by barge. We would argue that transporting coal by rivers to villages is environmentally safer than transporting large volumes of oil due to the potential of spills. If a barge of coal sinks, there's no little risk to the environment. Further, the pyrolysis oils and tars generated by and recovered from the gasification process provide additional fuel flexibility for on-site peaking requirements and or use of the liquids blended with oil for use in other CHP sites or existing diesel engines at a fraction of the cost of fuel oil. Before we can see HMI's gasification technology deployed in the villages, we must first demonstrate that it works. This is the primary objective of the North Pole demonstration project. Once we can demonstrate that it works at the 15 megawatt scale, then we can work toward demonstrating it on a village scale, 2 megawatts or less. Modular small-scale gasification is a timely development for extending the life of coal-fired power plants across the United States. With major infrastructure, coal supply, and operations already in place, existing coal-fired plants are logical locations for adding a syngas engine system to provide price-stable, flexible generation that responds quickly to changes in electrical supply requirements while complementing existing operations. Coal plants tend to require a long period to change the generation set points, rendering them less effective for meeting non-baseload generating requirements. By placing a syngas engine system at the interface of the grid, the syngas engine system can quickly respond to changes in load. Modular small-scale gasification technology, coupled to an engine generator, has the potential for making coal a cost-competitive resource for meeting the flexible energy needs of utilities across the nation. I wish to express my gratitude to DOE and NETL for funding this research. Also, I am extremely grateful to each of the folks listed here for loaning their expertise and talent to making this project successful. Thank you for your attention.
Right.
All right.
That's,
Well, I would, sir, if you don't mind. There was a lot of information there.
he'll cover it.
Oh,
And what I want to do now is I guess kind of take that almost to a bear with me, almost to a more simplistic level. So that was a highly technical presentation. It was focused to an audience that was, you know, our specialists in this kind of systems. And mine is a presentation that's really much more focused to people that don't do, you know, power generation or you know, and so I'm going to really start at kind of a more base level and give you a perspective on a lot of the same stuff viewed through another person's eyes. You know, there will be some replication, and I apologize for that. Didn't necessarily expect to do that presentation, but I think it's worthwhile to step through this now. Sorry, I've got a bunch of different screens. Oh, I'm looking at the Acrobat version. Never mind. I don't want to do that. I want to look at, hold on. Ah, here we go. I want the PowerPoint version so I can do full screen. All right, so
we're
we're
gonna
gonna
reshare. Actually, if you can just reshare really quick.
Oh,
Yeah,
let's
stop
stop
share.
new share. I don't want that one, this one now. Right? No, I want this one. And I think that's what we want. Okay,
There we go.
here we go. So my presentation again is basically looking at the same proposal from a different set of eyes. And I'm Dave Van Holde, again with the Washington State University Energy Program and the US DOE's Northwest Combined Heat and Power Technical Assistance Partnership. I've been working with these people for a number of months as an overseer to this to review this project. Okay. Now I just need to figure out this. Oh, here we go. Never mind. Okay, so again, backing up, what we talk about is what is combined heat and power, to give you guys a picture of what we do and how we do it, and then talk a little bit about relationship with utilities, which we think is really important, particularly in Alaska. Then we'll zoom in on the Marathon project, and finally I'll talk a little bit about what we do and, you know, how our work fits into this development process with you folks. So who we are, we're the Northwest Combined Heat and Power Technical Assistance Partnership. We're part of a 10-party group or 10 group. Apologies, I'm gonna stumble over my words a little bit. We have 10 centers in the United States, and I handle the Northwest, including Alaska. And I tend to focus in Alaska because combined heat and power makes an awful lot of sense up here, given the need for heat and also power, and the relative price of energy up here. Surprisingly, as a major petro producer, your energy costs are quite high. And that has really to do with delivery and the infrastructure as it now exists. And I think this project actually addresses some of those issues directly. What we do really is end user engagement, stakeholder engagement, and technical services. I'm not going to read the fine print, but suffice it to say that you all are stakeholders in this project. And my job here is to engage with you either in this forum or separately and talk about this project. We also do technical analysis, and I've been doing technical analysis with my team on this project as well. So really stepping back, for those of you who don't necessarily know what cogeneration or combined heat and power is, I want to take a few minutes to talk about that, because it's not a foregone conclusion that all the audience knows that. Well, combined heat and power is an established efficiency technology, and it's really what it is about efficiency that greatly increases the net efficiency of electric power generation supply compared to separate power and heat plants. So basically, when you marry a heat plant and a power plant, your efficiency goes up by a lot, and that corresponds to lower costs and lower emissions. And these are simple and really basic facts, and they're important because that's the basis of the whole case that we make. So your number one takeaway here is, you know, this is likely the largest net energy savings opportunity that a small power system, including the power systems in Alaska, can take. And again, very important, but again, there's nothing tricky here. And in the world of energy efficiency, a 25% net increase is almost unheard of. So this is really substantial. That's one of the reasons DOE is committed to combined heat and power as a technology, and has been for many years, because although it's been widely used in industry, it's integral to the chemical and the oil processing industry from years and years. And in fact, it goes as far back as Edison, because Edison's first power plant was a combined heat and power plant. The only reason we moved away from combined heat and power over the years is because a lot of power plants were big emitters and they couldn't be put in the middle of cities. So when we built big power plants, we moved them out of the cities and we built transmission from them. But new technologies, clean burning technologies, allow us to move the power plant back into the city or near to the city, and even into buildings now, because we have gas-fired buildings, we have gas-fired power plants, and the technology has allowed small systems to become as efficient as large systems. And we'll talk about that as well. So really, this is a marriage of an old technology, new technology, and a really compelling play, which is efficiency, right? And efficiency, as we know, is always the first way to save energy and to reduce emissions in general.
Just so you know, sir, well, if you don't mind pausing just 1 second, this is actually a fairly savvy group.
Okay.
We've been doing this for better 15 years.
Okay.
So you're good. You're in good company here. We know we got you.
Okay.
Second thing is, just want to remind everyone again, this is all for you. I am monitoring the chat box in case you have any questions or comments. I'm also watching the participant list. So if you have a question or comment, you can raise your hand.
Yeah.
But you can also just go ahead and come on mute, off mute and fire away. Again, this is for your benefit and for your information.
And I apologize if I'm talking about really fundamental things and folks don't know, but I can't assume that with all.
No, we like it for the record. We do get some other.
And really, this slide says it all for those who are visual processors. It explains why this technology works. And when we do analysis, basically what we do is we counter the savings against the capital cost of putting in a power plant. For a lot of people, that's just not something they would normally do. But when you get, a 25% net efficiency increase and the reduced costs associated with that, you can carry capital costs in a lot of cases. So I'm not going to talk any more about that, and I'll try to move forward a little more rapidly. And again, you folks really know this technology pretty well. And this is a slide that I tend to show a lot outside of Alaska, because I want people in Alaska or outside to appreciate that you folks have been doing this for years. You know about China, you know about UAF's power plant, which was highlighted across the United States as probably the leading coal power plant that was built in the last few years, because it uses very clean burning technology, and it also does CHP. So it's efficient, and its net emissions are greatly reduced by virtue of the fact that it is a CHP plant. But also we work with AVEC and Alaska Energy Authority to do installations in a lot of remote villages. And there was some allusion in Brent's presentation to the notion that you have a lot of off-grid communities where this really, really makes sense. And because they're paying top dollar for oil, and if they're not getting all the energy out of their oil that they possibly can, then they're making a basic flaw. And this is just as much as anything as an education process, but also a process of helping people walk through it. And I do appreciate that a lot of folks up here really get this, but I also meet a lot of folks who don't. So
I actually hadn't thought to add China's power plant to our list of CHPs, because if you include that, we actually have 5 CHPs in the community: the university, Aurora plant downtown, steam and water, and then the 2 military bases.
And I've worked and talked to all those folks over the years. So to let you know, my first visit to Fairbanks was in 2002, when I was working with another firm called eSource, and I actually came here to see the battery, because the battery is such a unique facility. But I went there and saw the old power plant up on the hill in Aurora, and more recently visited Aurora. And I know that Aurora and Fort Wainwright are looking for pathways forward, because its old coal technology is problematic. And I'm not going to get into politics of that, but I'll say people are looking for pathways forward, and trying to figure out how to do this cost effectively and in a relatively clean manner. So I don't want to get off track too much. So I do think it's really important to talk about why engagement with local utilities, and that would include both, interior gas utility and GVA is absolutely crucial here. In the case of down in the lower 48, you tend to be a small power plant in a really large system. And, while a local rep might, say, oh, I'm going to lose a big customer, it doesn't impact the overall system. But when you build a power plant in the middle of a relatively small power system or gas system, it has an impact on the whole rate base, as well as on the power distribution and or energy distribution in that. So it's very important to look for win-win cases where it benefits everybody to install a new power plant. And that could mean that the power plant was either owned by the utility or is owned by, again, a municipality, as is suggested here. But ultimately, everyone should be able to win in that situation. There's an efficiency increase if the thing is structured correctly. That's your hope anyway. I will say, however, that rather compared to the small microgrids, this system would be less effective because you are connected to the rail belt transmission system. You do have a substantive gas infrastructure, but it's still relative to, say someplace like California, where you got a huge network grid and gas system. It is more impactful, both in good and bad ways potentially. So anyway, that's just my point there. But again, I think there's opportunities here for win-win across the board. And I just emphasize to folks that it's important to move into those conversations and those negotiations early, rather than developing a project and going to utility and the utility says, well, wait a minute, what are you doing here? And it appears to me that that's already happening here, which is a good thing. And in fact, I know it's already happened. I'll just say briefly, again, this system would not be proposed necessarily as, it's not a microgrid, and it's not necessarily going to be a separable grid as such as you might see in Fort Wainwright or one of the, military bases where it's necessary to have resilient power under all circumstances. But it will be a microgrid as far as heat's concerned, because heat distribution is very limited in terms of geography. So again, one of the values here is to provide uninterruptible power potentially and increase resiliency locally, and also to provide power support for integration optimization of intermittent resources such as wind. And we'll talk a little bit more about that, because there's substantial wind development happening here under GVA. And I think that's part of the opportunity that exists. And again, this is just a schematic picture, very similar to what is being proposed here, with substantial thermal storage, in addition to a thermal distribution system to both residential and commercial customers. So let's talk about Marathon. One of the things that first struck me when I started working on this is that this is a great co-location opportunity, and it's all about physical geography in a lot of cases. The proposal here takes what's called a brownfield, currently a largely disused site, and revitalizes it economically by virtue of building a new productive industry within it that is compatible with the existing site. And that's good, because my understanding, and again, it's limited in this regard, but the Marathon site was probably a lot more active before and is largely a deep thing. But it does still have a substantial thermal load, because you have to keep the fuels and the oil products warm in order to be able to move them in cold weather. So there's a substantial thermal load there. There's also a substantial thermal load associated with a number of commercial tenants that are being considered, and there's conversations, and I'll talk more about this right now in a few minutes, with the potential to develop greenhouses, which would be a substantial, really quite large thermal load. The other thing that this site has is quite unique, is it has basically, when a lot of power plants are planned, they tend to be planned at the intersection of a fuel and an electric grid geographically, and this site has that characteristic. The electrical interconnection to the utility is much lower cost that apparently than what would be typical, because there's already a substation available that has capacity to take the power. But in addition, and even more importantly, your interior gas utility has an LNG storage facility right next door. And this is huge because you really can't transport gas, substantial amounts of gas, long distances. Well, I mean, you do it in a liquid form, but then you have to have separate storage. And this way you're allowed, the opportunity exists to just put a pipe in. In many sites, the choice of a gas pipe, power plant sites, the choice of a gas pipe and proximity to substantial gas is the driver because it's so expensive to build long distance gas pipelines. So as proposed, this is a project that would initially use natural gas for firing 2 engines and then ultimately develop to include coal gasification, which is an interesting 2-phase project. Any questions at this point before I keep moving forward?
Actually, I would ask a question. Please.
I mean, I have a lot that I've written, so I'll just wait for the end probably,
That's right.
Then my only is, again, I see that line running from IGU to the CHP. And then usually for start, it would be gas from IGU to the CHP. But potentially further along, it's gas from the CHP, syngas, into the natural gas system. No?
No.
Okay, so it's just the utilization of the gas.
Yeah,
Okay.
I haven't heard these guys.
I can tell you that the syngas that we make is a low BTU gas.
Mhm.
Its only
For
application would be
Got
to
it.
burn it. It's
Okay.
you can't use it for really anything else. It's just, so we're not.
Oh, that's fine. Okay.
Other questions? Okay, I'll move on. So, and now we're looking again at a slide that you've already seen and anticipated that, but I think it's really important to, when you think about that proximity issue, to talk about the co-location benefits, right? So in this case, it's relatively easy to export excess power onto the grid. That's the best way to do it. That requires a contract that's amenable to GVA and that works cost effectively to sell power into the local wholesale market. But the electric customer, I mean, the heat customers have to be proximal and they are, and that's already been lined out. And the goal, of course, in this thing, and this is where the detailed economic analysis that we've begun is to be able to provide reliable heat at substantially lower costs than the alternative of building separate heat plants throughout the area and with these major customers. That can either happen in terms of just the major, what we call anchor tenants, like you can start this project doing the analysis of assuming just Marathon and a couple other major customers, the district heat, the water heating demand of North Pole's water supply, which is really a substantial continuous heat load. And I understand Three Bears is looking to move in there. So if you have, 3 large base load customers, those could support the base economics. And then you start to talk about whether you want to build out a larger district heating distribution system. One of the things that has to happen is it has to be able to support the capital costs of developing that distribution system. And this is what, again, this kind of expands the physical proximity picture for you. So what we're looking at now is another aerial photo that's been moved off to the, I want to say to the right, but I guess that east, yeah, okay, thank you. And again, you can see right down in the lower left corner, the CHP plant would be located there, and the IGU natural gas depot is right where the big yellow arrow is. And proximal to that is this whole development area that I would leave to others to discuss later on, that could be potential customers. And I think Three Bears is somewhere in there.
Three Bears, if you'd like, I can point those out. I don't have the pointer, but I can go up and point them out. Do you have a pointer for me? Or
There is the cursor.
Oh, yeah, I can.
okay, if you'll point out that whole area up in there that you're running the cursor on,
Yeah.
So this is all Brookside Park. So there's a track D, which is 45 acres, and track E to the right of that, to the east of that's about 11 acres. So it has the potential of, I'll call them domiciles, 300 domiciles between track D and E and the green. Way over to the right, to the east, just keep going over and down, go straight in, go back to your left a little bit. Up in the green area, which says track C.
Okay, right here.
No, those are homes that are already existing from 30 years ago,
Okay,
right there. That whole track back and forth there, that track C is 25 acres. That is where Three Bears will potentially go and any other tenants that come on that property with them. That's zone commercial. The tracks D and E I showed you were zoned multifamily residential. And then I'm going to go up here because it might be a little faster for me to point them out. David, this area over here, I've been in discussion with the borough, may need to be rezoned. But this is track G. You have 14 acres of multifamily right here, and you have 40 acres of light industrial. The GWP is groundwater protected, and the SL means there are special limitations. So that's going to take some exploration, what we can do with it. The rest of this is, most of these lots are sold, and it's pristine. And we want to keep it pristine. And that's what this combined heat power help us do too. Is keep it pristine. So a lot of users that could potentially come out of this.
yeah, and this is the scale at which, you know, the low, sort of locational scale at which district heating can work pretty well. I'm not gonna talk about this, just another.
Same map.
Same map, just more. And then I want to visit the equipment as was lined out by Brent, but in a less technical way. This is a two-phase project as envisaged, and phase one focuses on the natural gas engines, which are actually larger, but there's only two of them. And in my mind, this is a relatively sound strategy because it allows the region to step into the project and basically start to build the combined heat and power and district heating infrastructure, you know, for those base load tenants with less capital commitment as they start to do the brownfield development, and they can you know, develop the coal gas syngas gasification plant and bring in the much larger set of 6 engines that would be installed in phase 2. So really a two-phase project, you know, it's just a more reasonable step than trying to grab the whole thing at once. Obviously, it all depends on funding and what's available and you know, the kind of analysis that will be needed for emissions and permitting, right? But the natural gas phase should be relatively. Sorry.
No, before you leave this slide.
Yeah.
We do have a question here in the chat box relative to those low emissions. Do we have further discussion of emissions relative to the non-attainment area?
There is not in this slide set. I think that's a detail. The emissions analysis is detailed.
We have done an environmental volume that looks at this, and we started down the permitting path, and we're pretty confident that we've got the technologies. Certainly with the natural gas, there's not going to be any particular problem with permitting. With the coal aspects of it, we've thrown everything, including the kitchen sink, at it to make sure that we can come in and meet the PM 2.5 non-attainment requirements.
And we have identified a group out of Anchorage that would come up, monitor this whole area prior to us doing anything, say, here's where you're at, so 2.5, and then continuously monitor as we go along, especially when we go to coal. It would show, okay, they're right, the greenhouses are absorbing all this. There is no PM 2.5 contributed from us. I mean, I had enough to know that we needed to do that. So we've already got them identified.
Just another quick aside here. Our final report on this project will be available on the NETL website. I submitted it already. They made a few edits and sent it back to me. I haven't completed the edits, but there is the third volume is an appendix on the environmental volume that addresses many of the aspects that people might be concerned about here.
And actually, that was one of the things when I first looked at this project that really intrigued me. I just finished a biomass gasification study for the U.S. Forest Service, and we were looking at a plant in Denmark that was using a very almost identical wet scrubbing system to take the tars out, because you have the same issue when you're burning wood as the Danes do, and the Danes are super strict about this stuff. And this wet scrubbing, electrostatic wet scrubbing, takes out basically the tars and captures them. And that's a really significant part of this whole process, especially for the gasification side. Obviously, in the phase 1 step with the natural gas, you don't need that. But when you put it in gasification, you need to have a way to clean up that low BTU gas before it can even go into the generators.
I have one more point. I noticed now the question also says including the CO2. So we don't have any plans to particularly utilize the CO2. No, that's not exactly true. There was a company that asked us about purchasing CO2 off of our plant. I said the technology is way too expensive. There's no way we can do it. Then they took the mayor and me out for lunch here a couple of weeks ago, and they said, I totally misunderstood. They have a CO2 capture plant. They just want permission to plop it down next to this. And they would own that CO2 plant, capture the CO2, and then they would sell it to the greenhouses throughout Alaska. Apparently the marijuana industry is creating quite a demand for CO2 fertilization.
And we're talking about medical grade CO2.
Yeah.
Yeah.
And-
Pharmaceutical
high
grade.
level.
And then with respect to the gasification, when we get to that point, or if we get to that phase, all of those emissions are going to be treated and passed through the greenhouse. I don't know if you're going to talk about that. Our calculations suggest that greenhouse alone will absorb about 50% of the CO2 that comes off of that coal gasification plant. And then if the others customers would adopt district heat as their primary heat source, then there will not be CO2 generated from combustion generation devices within the homes. And if we're allowed to accept credit for that, then our plant is essentially CO2 free, and we think that these homes, if they're built without their internal combustion for heat, we think that the homes can be certified as net zero. But we're not sure, because I mean, obviously the plant is still emitting CO2. So it's all in how you balance all that out.
Did that cover it, Gary?
So I'll move on.
Yeah, that's fine.
I think it's also worth noting that, just briefly, and this is a kind of a busy slide, it's pretty technical, so I'm not going to go very far except to say the use of relatively multiple smaller engines is a good strategy. And the reason it's a good strategy is it allows those engines to run at full power. Whereas when you have large gas turbines that are often used in the region to generate electricity, and they have to go ramp up and down to meet load and particularly to meet the demand for shifting resources and intermittent resources like wind, your emissions are taking a hit potentially. So in this case, with what are called relatively small, and to most of us, a multiple megawatts sounds like a lot, but in the power industry, it's not. If you're able to have, smaller generators, then you basically bring one on, you stage the next one on, you stage the next one on, and that way you keep yourself at your full efficiency. And these gas engines are actually quite efficient. And once you add the combined heat and power, they're extremely efficient. So the idea of being able to stage is really important. It also gives you more resiliency. And what that means is if one power plant fails, if one of the engine fails, you still have others. And that's another nice aspect of having multiple engines in a system. We have, just began touching this conversation with the local utilities, but it appears there's a need for this kind of dispatch to support shifting resources in the region. So that's basically all I'm going to say about that.
I will tell you, I didn't realize until just Tuesday, our local electric cooperative gave a presentation. Just how large a percentage of their fuel currently is oil.
Yeah.
I had no idea.
What percent did they come up with?
The number from the presentation was 38%, almost equal to the coal load.
Yeah. And one of the real problems with that is volatility, right? In addition to the emissions issues, there's real volatility with that. So they can take a super hit, and usually they have surcharges they put on your bill, right?
Yeah. Well, their LM6000 is how they chase. It's how they load follow and and chase.
But still, this, an LM 6000 is more like that lower curve that, that has, it doesn't like to run. All these gas turbines want to run at full load. And when you've got a, I think an LM 6000 is like 50 megawatts or something like that. I don't remember the exact number, but it's big. And so it really wants to run full load. If you have to turn it down to follow the load, the emissions really fall out.
Well, they do though, because it's their most responsive unit.
Yeah.
Mainly.
But they do, but the maybe responsive heat does lose efficiency. Anyway, I think the argument can be made that I'm sure it's generated by GBEA. So I really want to talk a little bit about this partnership with greenhouses, because I work on this conversation with a lot of people around the region. I just came from a conference actually in California on a national conference on what's called controlled environment agriculture. And what we were talking with them about is the marriage of CHP and controlled environment agriculture, which is a really very active topic. It began, to be honest with you, in the Netherlands, and they have like 3,000 megawatts, 3 gigawatts of CHP powered greenhouses in the Netherlands. There's also a lot of it up in Ontario. This has been going on since the 90s, and it's gotten very mature, and there's a lot of investment in the United States now to do this as well. I won't pretend that it's a panacea, but it's a very attractive option if you can structure the deal right. And it's very important that you find the right partners to do this. Typically, the people who operate these greenhouses are not your regular farmer. They're greenhouse farmers, and their business is to work in closed and growing environments that are, operated very differently. And I'm not really talking about marijuana. In fact, to be quite honest with you, I'm not allowed to talk about marijuana when I'm working for the federal government. I'm talking about foods, flowers, kinds of things, basically high value products that people want locally produced. And
Marijuana is not allowed in the city of North Pole from the point of growing it, selling. You could do it as an individual, but we can't do it as a business.
Here, I'll make this easy.
but
Here at FPDC, again, we just worked on the community SEDS.
Yeah.
For a long time, we've helped support community agriculture.
Yep.
And again, we're talking about food production.
yeah,
The SEDS is food production.
Yep.
And the 3 brass rings infrastructure components that the community in order to try to help community agriculture are first a commercial processing kitchen.
Yep.
Where they could take the things that they do create in the summer, scrub it, package it properly for sale within local sellers, grocery stores and the like. The next one is cold storage. Again, having been processed, freeze the excess and extends the selling season.
Right.
But then the brass ring, of course, would be commercial greenhouses where we either very much extend the growing season or we make it year round.
and I appreciate the audience may be skeptical about the idea of carbon capture in this setting, but it is proven, and it is being done, worldwide. And I can tell you that the Dutch are not, they're not faking this. This is actually measured, and it's not 100%. It's probably somewhere ideally around 50%, but it is a place for that carbon to get captured in a straightforward way without a whole bunch of chemical processes. So what does this look like? Here's a great example. I just love this one because this is in Utah, and it's a setting not unlike yours. It's a relatively cold climate. On the right side of that slide, from my view, is a 550 megawatt combined cycle plant that Pacific Core operates up there. And a developer named Howling, who's one of the ones that I guess these folks are talking
We're
to,
talking to them. Yeah.
came in and basically said, I want your off gas. And this isn't the only place this happened. The reason, a lot of times they actually put in, site specific cogeneration systems inside the greenhouses. And there's companies, international companies that do this as a business model. But this one always struck me as really interesting because it was a marriage of a large merchant power plant, where the merchant power plant was already a very clean burning natural gas power plant, but improved its environmental profile and also supported a big greenhouse. Now that's not much bigger than the one you're talking about. That's about 24 acres right there. This power plant could support 100 some acres if they plan to ultimately build it out. But again, that's all about the market. But I want to tell you that I've looked at many of these sites, and they're non-trivial exercises, but they do work. And you know, in Ontario, there's 3,000 acres under glass. It's just sort of south central Canada, and they're also supplying energy to that power grid. And that's this quote I got here, where in an advantageously structured power purchase agreements, the heat and CO2 have been basically free to the greenhouse. That's this one of the early and ongoing developers in Ontario said, this is how we structure it. Now, I won't pretend that we're dealing with Ontario Hydro, that's not our utility here. But if it's well structured, again, the idea is for everybody to benefit, right? And so you try to balance the values of heat, power for lights to extend the growing season, CO2 capture if it works, and you know, and everybody hopefully wins. So it's really, I call this one a win-win-win because there are a lot of dimensions of value there. So basically what we like to do is help people develop projects, and that's, you know, that's what we do here. That's what we've been doing elsewhere. We usually work through these kind of conversations. We do technical analysis. We have a technical analysis team with a fair amount of depth. And our job is to help you determine whether, you know, whether the economics make sense and before you move on to spending a lot of money on engineering studies. So if you want other information, I can send this presentation out. You can look at it. You can look at the other data that DOE has on it. So with that, I thank you, and I hope that I can answer any questions you might have.
All right, well, newly mentioned
Yeah.
representative staff here appears to have some questions, please. Will.
Yeah, I'll have a few. So I like money, so I need numbers to preach the language here. So when I look at this, conceptually, I really like this idea. Why? Because it takes all of our existing kind of tools and puts them together for some sort of good utility. So my kind of first concern is 21-acre greenhouse. So just looking at some of the numbers, so you can produce 2.5 pounds per square foot of vegetables. You aggregate that by the land, you're looking at 2.3 million pounds of vegetables per annum. What is the cost production efficiency of 2.3 million pounds per vegetables as far as ROI sold back to the consumption? So like, what are we actually talking? What is the cost to produce versus the consumption of the domestic market versus the transportation cost, inverse to, you know, fuel price?
Good questions. You'd have to ask Casey Howling, unfortunately, because he's
Can
the
I try
greenhouse.
to answer some of that? I do know, because I know Casey Allen.
Yeah.
Go back to the picture of the marathon site.
Oh, yeah.
Yeah, so that's
So Casey, he has some of the largest greenhouses west of the Mississippi. And to give you a little bit about his background, his father started in Delta, British Columbia in 1956. His heritage is from the, okay. He was up in 2011 trying to get the Matsu to take him on. And he couldn't get from Matsu Electric the cost for electricity. So it was prohibitive, cost prohibitive. He could sit there talking about the transportation cost. He could sit there with his QR reader on his phone and say, oh, this came from my facility 11 days ago out of California. And he knows how much it is expensive to ship that. And then but we're talking about back in 2011. Imagine what it will cost today to ship those things. If you want to know about Howling tomatoes, go to Walmart. They'll say, if you want to buy the very best, you buy Howling tomatoes. But imagine if they're grown here. So now you don't have the transportation cost either from California or Utah. But not only that, I'll put it this way. To build that 20 plus acres is approximately $2 million an acre. It's hydroponic. So we're talking about 40 million, but he is an entrepreneur. This is something that he has signed on. So, you know, this isn't something that it's to be made up at the other end. I don't know how many different crops will grow year round in these greenhouses. Okay, you've got 20-something, $40 million of investment. Anybody who's willing to take that on as an entrepreneur wouldn't be doing it if they didn't think they were going to make it at the other end. And so, you know, we don't have the food sustainability that we need in Alaska. This helps us meet that. But to tell you specifically, we would have to go to him and say, Casey, and whether he will release that, disclose that to us, he would to us, but whether he does it to the public at this point, I don't know. But that's the things that I do know. If I don't know something, I won't tell you I do. Yeah.
And I don't mean
I
to
can
knock the
offer a
project. I
couple-
like the project a lot. You guys speak
Yeah.
my love language, guys.
Yeah.
Money.
Yeah, it's money.
So I can give you some perspectives on that too. The developers, first of all, you need to find a developer that wants to do this, and they will decide if they like the prospect. They'll look at the market, they'll look at, the local distributors and the local retail, and they'll say, does this market make sense to us? Because they're gonna invest the money.
Mhm.
And that's as important, probably even more important than even just the money, is that you have to have people that can operate this, because you can train local people, but you got to bring in the people who know how to operate these greenhouses, because it's really not trivial. It's a different kind of growing environment. It's not like you take farmers from the Matsu Valley and say, oh, you're going to grow inside a greenhouse. It's a whole different business. So the investors, the people who bring that $40 million to the table, they look at the whole picture, including staffing, training, developing the whole thing, and they say, does this make sense? And I can't tell you whether it will make sense, because when I deal with these people and talk to groups, I'm talking about the energy side of it and the CO2 side of it. This package technology exists. I can turn you over to people who are developing these projects all around the country and the world, right? In a matter of days, and they'll talk to you about it, and they'll decide, you and them will decide whether it's a reasonable prospect. But they won't move into it unless it makes sense to them. And I know it's a goal of the governor, and there's a lot of reasons, food security to think about this. But again, you got to be very honest with yourself and say, what are you actually growing there? You're growing premium products. You're not growing, corn.
I have a related question,
But let me just bring off that while I have it fresh on my mind. So the Deputy Consulate General of the Kingdom of the Netherlands and his economic advisor were with me back in June. Why? Because they knew about us from SpaceX in May. So he says, why? Why does little North Pole care? I said, because y'all are the world experts in this agriculture. And we know that we need to have a pipeline to those experts who come up here. Because he knew Casey Howling as well, because I told you Howling's heritage goes back to the Netherlands, okay?
Yeah.
And at the same time, he says, well, what will your market be? So it's no small idea that Three Bears wants to market that. And by the time they open our store this time next year, they'll either be store 24, 25, but they're already in Walmart, Freddy's, Safeway. So we would now have a way to bring that about, is to say, we will be able to put whatever we put in those $40 million, you'll be having a market. Plus, I envision in my own mind that we'd have a marketplace there in North Pole as well for people local to buy it as well. So I think they're the entrepreneurs. They're the ones who are going to make the money. They're the ones who are risking their capital. Most of the ones I talk to don't want federal assistance or anything. They have the ability to do it, So, but now, thank you for letting me throw that in there.
yeah, that's right. So earlier you had mentioned the Utah plant there. So they had a 24-acre greenhouse, but it could be much larger, like I think you said 100 acres.
It could, but that's because that's such a large power plant. I mean, it's a 500 megawatt power plant. It's big.
Yeah, my question really was when you say a greenhouse adjacent to this plant here, define the limits of adjacent. Only because I live out on the house on Farm Road, so there's a lot of ag land out there. So if there's an opportunity to go, you may go introductory with that 21-acre thing there, but it might be able to expand out across that bridge there and into the Eielson Farm Road ag land there and be much larger in scope, which means there's a greater impact.
But that's adjacent, as you see on that map. You can't get any closer than that.
No,
Yeah.
no, I'm talking about
But you're
this
about
is
expanding
far.
later.
Yeah, how far away could you
Well,
be?
I can explain it this way too. This is something I do know from going to all of Howling's places. If you took the traditional agricultural acre versus these high-tech, it's 24-1. So like if Howling has 125 acres in California, it's the same as if he had 3,000 traditional acres.
No, I understand. I get
That's
that
huge.
part there.
Yeah, I don't think.
But three
I'll-
or four more miles down the
I'll
road
allow
there.
this out. So this is the original patch report. When FEDC looked at the possibility of putting an industrial scale coal, natural gas, and biomass to liquids. So it was going to be gasified, but then using Fisher-Tropsch to make liquid fuels. We were told that you could push usable power heat up to 30 miles.
I wasn't concerned about the power and heat. I was more concerned about.
Yeah, I
the
think
ag
your
side.
question's a good one. First of all, I would say it's demonstrated with natural gas. It's not been demonstrated with the gasification gas.
Right.
But I would say it's not necessarily out of the question, because by the time you clean it up that much to run it through the engines, what they do when they use a natural gas engine, they do post gas engine cleanup with catalytic reduction, because they're gonna take that exhaust from that natural gas engine, they're gonna pipe it right into that greenhouse.
No,
And it has to be they actually have to moderate it, and they have to make sure all the nitrous oxides are out of there. It's just basically carbon dioxide and air. And they have to add excess air so people don't suffocate in there. You need to keep the levels. They do this very, very carefully. It's not really transportable, because the whole idea is the exhaust comes straight out of the power plant and goes into the greenhouses. And so the proximity has to be basically right next to it. That's not really transportable.
Well, again, would we be heating these greenhouses with the exhaust gas or
No,
with hot water?
you're heating the greenhouse with hot water, but you're injecting the gas from the CO2 value.
Just know that theoretically with hot water,
Yes,
you can push it a long way.
absolutely.
No, I get that. I mean, I spent the last 30 years on a house. So I'm very familiar with their power plant. So.
Yeah.
So I have another one too, if you indulge me. So I might be the only one who's actually.
By the way, again, I will open it up to
Okay.
anyone online has questions, please take up your hands.
So I might be the only one who's actually been to Stebbins. Anyone ever been to Stebbins? I've been.
So my former son-in-law.
Yeah, there
We
you go.
bought out there.
So yeah, so I understand the application in Stebbins completely, because there is a lack of what you can do in Nenana, which is biomass, right, for combined heat and power. So my question would be, again, kilowatt hour per price combined heat and power syngas, as opposed to simply biomass like you're performing in Nenana.
I do have the numbers here. Our phase 2, if we go to syngas, is designed to take 20% municipal waste, primarily the cardboard, paper, and plastic pellets that would be designed. And I have the numbers here, and I just don't have them
Okay.
in front of me. But if you were to do, oddly enough, when we were doing and work with the environmental permitting piece of it, it's really hard for us to get that fuel mix permitted. We can permit coal because everybody understands coal. It's been burned here and everything. But when you add the municipal waste, now suddenly you have a fuel mix that's unpredictable, and curiously enough, it's harder to permit an MSW project than it is something that's based on coal. But our design is 20% biomass. Our plan is to instrument the heck out of the whole thing, so we get the baselines going in there, and then we can start playing with the fuel mix. As an aside, we're just starting discussions with the Electric Power Research Institute, EPRI. They already have existing projects where they're taking plastic bottles, plastic waste, putting it into gasification units with coal. So we're now working out an arrangement where we can consider that for our plant as well.
And I would echo that too. The difficulty of the upset that happens whenever you change the fuels is one of the big problems that you run into in permitting. And this happens with CHP systems and just switching from gas to oil, because a lot of systems, they would, especially on military bases, they want used gas, but they want to have reserve fuel in case they have to go offline. And they can't even test them because they have permitting issues. Because the combined heat and power systems, permits are designed for gas. This is, I guess my only suggestion is be careful, because you're going to design a gasifier for coal. The minute you start mixing the fuels up, it may not perform the way you want it to. And we've looked at biomass in the region, and generally, we're big supporters of biomass systems that are around the Northwest. But the scale, when you get to this scale, there's probably not enough biomass to regularly feed this thing. Although you might like the idea, there just isn't enough biomass being produced in the region, and you don't want to overproduce a region. A beautiful case study, I mean, beautiful model has been done at Galena by that guy who built the biomass system at Galena. He actually studied and determined his sustainable yield, riparian area on the Yukon. He's got an awesome project there, but he's looking at, a specific power plant, a few million BTUs to heat the Galena school, and if you start thinking about this
Without
scale,
electric generation.
without electric generation, yeah. When you start about this scale, you need a lot of biomass.
Another thing we were offered some years ago as a community, a cutting edge gasification system. I don't know how cutting edge, but it was supposed to run off of biomass. And yeah, the volume, it was going to take every shred of garbage created by the borough, plus the military bases to run it. And I meant every scrap. Hey, Carl.
It takes a lot of biomass to create power, as they've found in Toke, and so much of that potential heat just goes right up the stack. And I talked to the operator there in Toke, and they said that they wish they had more places to sink that heat into, because to create power and with the steam engine there, it just takes so much, which is why we decided not to do power. And not to mention they were paying 75 cents a kilowatt. And so that margin was way bigger than ours, where we were paying 20 some cents a kilowatt. The margin's so small, it didn't make sense for us to do electricity. But it's true, it takes so much for power generation with biomass.
That really needs, sorry, did somebody have a question?
Looks like, yes, Mr. Bulkey.
Yeah, if you can go to that chart with your generators, phase 1, phase 2. Okay, so in that one there, you described that phase 1 is going to be the initial generation to get things going. And then once you start producing the syngas, then you bring those generators online after that. Then what happens to the natural gas generators? Do they go offline when the syngas generators are producing?
Can I take a stab at that?
Go for it.
We don't know that necessarily yet. At the very least, they would have to be there as backup capacity. But I can tell you that phase 2 will only come into play if we get the greenhouse going, because that's the anchor tenant, and it's a lot more capital intensive. So there's a lot of things that have to come together. When we went out for bids on the selective catalytic reduction things so that we could take those emissions and put it right into the greenhouse, nobody would give us guaranteed performance on their packages because of the fuel is unknown. So the only guarantees that these vendors would give us is if we run those 2 natural gas generators all the time to produce the CO2 and the emissions that they know they can treat and go into the greenhouse. So as far as I'm concerned, those 2 natural gas engines would run in perpetuity unless we can convince or develop an SCR that lets us fully treat those emissions to put into the greenhouse.
Okay, thanks.
Will. Oh, all right. Well, then I would open up the floor. Do we have, again, this is very interesting presentation, a lot of information.
So
Mr. Mayor.
do I understand correctly that the power, the combined heat power, that is going to be something that is sold through a power purchase agreement to Golden Valley, the power?
Well, what we're trying to do is initially, let me back up. So for phase 1, the only thing that's going to make sense is if we have a market for the electricity. And I've approached Golden Valley. We're just starting conversations. I mean, I wouldn't want to characterize it as anything more than just starting the conversations. But ideally, thanks to the mayor's good work, we have a long client list of people that really want heat off of the system. And the only way that we can make that economical is if we also sell some electricity. So some of our customers that would benefit from the CHP plant have a high enough electrical demand that if we could sell electricity just to our clients, then this thing would be economical. However, under the regulations, Golden Valley has the rightful monopoly and so I can't sell to those clients of ours unless I get special permission from Golden Valley and the RCA approves. So that's my approach to my friends on Golden Valley that are listening in. That's where we started. And where it ends up, I have no idea. But I can say, is that one slide that showed the economics early on, if we aren't selling a little bit of the electricity, then it's just, you may as well just buy the gas and put it in boilers. It's a lot better deal.
Yep.
However, I would also argue to Van Holde's point earlier on the regulation. Some of the stuff that we've been looking at and talking to different parties about, it seems like these two gas generators would be called upon quite a lot in the summertime for wind regulation. And to me, if we can cut a deal with Golden Valley to do something like that, it would be good for both the IGU and for us, because our demand is going to be in the wintertime. IGU's biggest demand is going to be in the wintertime. But if they're pulling natural gas to run on these engines in the summertime, we level out our costs throughout the year. It would be a really, I think, going to his point earlier, it would be a win-win for IGU, Golden Valley, and us to look at this, because it would be economic development in the community.
Yeah, because that was my very first thought in listening to this is, unless you guys were your own power authority, you're going to have to work with Golden Valley to sell that power, which means that customers can't pick and choose who wants the power or not. It's all going into the grid. And so making sure that Golden Valley is on board with that, which sounds like you guys have started that, is obviously crucial. But logistically, even if you were your own power authority, what would you do? Run your own power lines, and and how would that work? It doesn't seem to make sense without doing it through Golden Valley.
Absolutely, right. And regulatory wise, it's, and related to that, that slide that showed the neighborhood that could provide district heat, that would pretty much be the only market. It would be probably not economical for the CHP plant to go too far.
Once again, because of proximity, you're looking at 1/8 of a mile and no more than 1/4 of a mile from that plant going into Brookside Park. So 1/8 of a mile, 660 feet. So
Yeah.
1/4 of a mile is 1,200, 1,300 feet.
So I just want to clarify that, right? So are you saying it's going to go down Lawrence Road to the highway?
Nope.
And over the
Go right across the old Rich. You know where the Grange is?
Yeah.
Right into Brookside Park. Not down Lawrence Road. Lawrence Road is too far away.
If you pulled up the map, you could show.
Yeah, pull up the map.
A big map.
The map that had
The aerial.
page 10, I want to say.
There you are.
Yeah, that one. Or go to page
Well,
10.
no, this one I think is better
That
because,
does too.
because you can see there's a right of way even cut in right there
You know
already.
Busby,
So the right of way would be cut in.
but I wouldn't go down that way. I'd go more.
You want to go to the next one?
Yeah, go to page 10, please. 10. Well, you go to that, page 10, sir.
Oh, I'm sorry.
I've memorized these pages. Because think about it.
Easy way to move this.
So right across the old Rich over here, where the Grange is at, and that's the western edge of Brookside Park. So you'd be there. And the furthest place you go, track C, is on Busby. So now you can go to page 12, I think, sir, if you want to. So here's track, I'm trying to point it to you. I can barely read it on here, but here's your track C where Three Bears would be. That's the furthest from over here. This is the closest.
Okay, to Busby,
Yeah.
Busby and Lawrence.
Yeah, I don't call it, So I'm staying in the city limits of North Polk.
The bottom right corner of that block there is Lawrence.
Yeah, it might be, but you're not coming from around this way. You're coming from overhead this way. You see what I mean? You're coming right over top of.
So you guys are going to create a utility.
We could. We.
So has that been factored into all this capital investment there?
Yes, it has.
I'm just asking.
But right now, the people we're dealing with, we are not disclosing all that yet till we know that they will shake hands with us on it. We're trying to establish an MOU, as we said here. So,
With hot water, they sometimes do direct burial too, with insulated pipes, so you don't necessarily have.
No, I
to
know
build
that. I
concrete.
use that kind of universally.
Yeah.
Okay.
so we look at the whirly things, we look at what it costs per trench foot to get there. So we already know at some point for me to get from over here to here and to here, that's already an established neighborhood. We're not even worried about going there. But to get there is approximately $2.4 million on what it would cost per trench foot right now.
So you're not going to reach into the existing neighborhood?
Nope, absolutely not. I live in an existing neighborhood.
Oh, I know you do.
Yeah, no, we wouldn't reach into there. We don't want to take someone's current customers away from them. We're just looking at Brookside Park. That is Baker subdivision and North Star subdivision. I'm not looking at this. I'm only looking at Brookside Park. And that's a planned urban development, and it would be proof positive, small scale, not large, and says this is what we were able to do, almost as if you were in a village somewhere. Yeah, we're trying to keep it scaled to that point, not overdo it, not overextend it.
All right. I have one final question. It's a political one though. Given that the president said there will be no new coal-fired plants here, how's this play into that?
I think that's the $1,100 question. I
It's
mean,
synthetic gas, though.
it is. You know, this is about as clean as it's gonna get, and, you know, the carbon question is gonna be the question, right? And so,
Are there any tax credits or anything that you?
I would say certainly that for, you know, I won't say certainly anything, that would be a big mistake. This stuff tends to go down to what we call spark spread, the relative cost of the fuel versus the electricity and the heat. So it's a fairly simple calculation, but you know, one of the nice things about the coal is it gives you economic certainty on price as opposed to the volatility. As far as tax credits, what I hear is that projects in natural gas will sunset after 2024. And so somebody told me that you have to get 5% of the project, you know, commitment at that point. And, but again, I am not a tax guy, and God help me, I am not a federal, you know, how that stuff all.
Thank God.
Yeah.
Yeah, that's why we.
So I'm not gonna speak for that, but that's what I've heard. I've heard that if you were gonna build this CHP plant, you would want us to put 5% down by the end of 2024 to after the 30% IT investment tax credit, which is a really big piece of it. I'm
Yeah.
assuming investors are used to it.
If I could jump in, so the natural gas system that we're talking about, remember, this is 2 phases. So as excited as I am about the coal gasification in the greenhouse, that's a lot of capital. And that's, in my opinion, significantly farther down the road from now. And maybe the winds will change, maybe the price of energy will speak for itself. But for right now, you know, we're only talking about the 2 natural gas engines and build that momentum and get it going. And then down the road, once we have the financing arranged, then we would build a gasifier. This project actually started many years ago under the Trump administration. And the original plan was that we had competed for and won an award from Department of Energy that, you know, originally we were going to put this on the University of Alaska Fairbanks. The Department of Energy would have paid 80% of the capital cost for it because it's a demonstration project. But then for whatever reason, the university didn't want it anymore. So we lost that opportunity to build at an 80% subsidized rate. So now we don't have any subsidy. And it's actually, I think, better for the project because now there's no hiding what the real cost of this thing is going to be, right? So if it makes sense on its own, it can happen. If there's a subsidy, it's just gravy, if you will. But the economics are going to have to speak for themselves. And I'd say, sitting here, that it looks economic today. If there's a change in gas prices, a change in oil prices, a change in, it might not look so economic down the road. But right now, sitting here today, it all looks really good. We got a lot of tailwind on the
Yeah. Is
project.
there a negative impact between reinvesting that plant site and Eielson Air Force Base?
Negative, I'm sorry, I don't know.
I don't know how putting all of that into that plant site there takes away from anything that's already existing there in its relationship with Eielson.
You
Does
might
not
want to
take
talk about the
anything.
housing aspects.
Of the housing aspect.
Not the housing part
No,
there. I'm
you're
talking
talking
more from an industrial perspective.
It does not take away. No.
No,
Yes.
no adverse.
No
impact.
adverse ends that we have been able to identify, and I've been on the project 2 years and 2 weeks now. But I wanted to ask while we're in here, see, I committed this community goals chart on the wall. I committed that to memory. Is that from 2020 or 2019, Jomo?
Oh, that's way older than
I
that.
want to know because,
2012.
okay, so this is before the IGU was stood up,
This was part of us trying to figure out why we would stand up an IGU.
why we would stand up an IGU, which was being decided.
To try to effectuate those
2012,
goals.
yeah.
Yes, sir.
Because I testified the first Monday in October 2012, why we should. So with
And
that,
actually, I think it's even older than that, 2010.
yeah, but I did that in October of 2012. So if you look at a community goal in the middle, it says $15 per MMBTU. And Brent Sheets, who backed me up on this, we are there.
We're at $8 in MMBTU.
Yeah. Yeah.
Full
I've always kept
gasification.
that in mind. Right now, you see $3.90 a gallon. I wish I could get heating oil for $3.90 a gallon. I have paid as much as $5 and a dime. My city has paid as much as $4.84. So I do the conversions in my head real quick. So we have been as much as $44 per MMBTU on heating oil. And gas is real easy to convert. So if what we're getting is $22 right now, that's the same as $22 per MMBTU as well. So, but I could bring it in a heck of a lot cheaper.
For those who can't see the poster,
Yeah, I'm looking at the post for the wall. So
when we're
that's why-
talking about $15 per MMBTU, really what we were talking about essentially was a commodity heating, home space heating commodity conversion rate, or as a target, which is essentially $2 a gallon fuel oil would be about $15 per MCF for gas, or MMBTU for gas, roughly equivalent to 5 cents per kilowatt hour power if you were going to try to heat a space with electricity, and about $270 per cord for wood.
So I'll be bold here and say just a couple of things that are really kind of forward with me and do not have any kind of justification. But I just want to put that out there. As a lot of you know, there's a big and rich conversation going on about small scale nuclear as well. And I just want to point out that CHP operates well in that context too. So in the in the unforeseen circumstances of the future, any investment in district heating can also match into that potential future. I know Eielson's looking very seriously and may be the first site for
By 27.
for the SMR out of NuScale. And so just something to keep an eye on. The other thing I would say is if I were going to the government with an interest in funding this project, I would also explore deeply the notion of carbon capture on the backside of this gasifier engine system, because you're going to have to do the major cleanup to get into the engines. And if you can develop a cleanup system that can, be good enough to take that syngas out of the engines and then use it either in carbon capture or right into the greenhouses, you'd probably raise a lot of interest. And I'm not saying that that's doable. I'm just saying it's something to explore, right? Because you've already done a lot of the cleanup coming out of it, and then you run it through an engine, and now you probably have NOx and SOx, but you're partway there, and it's certainly something.
Well, this company that's interested in capturing the CO2, I mean, it would be medically grade.
Yeah.
So it wouldn't be capture, it would be beneficial use.
Yes, that's right.
Related to that, we're working on a project with the state of Alaska right now, with the state government, to assess the Cook Inlet area for CO2 storage, as well as maybe the interior and the North Slope. And one of the interesting things that we found, just preliminary, is that the cost of capturing CO2 off of all the natural gas generations in the Cook Inlet is super, super expensive and difficult to do. It probably doesn't justify even the $85 per ton 45Q tax credit. However, if you replace all of their natural gas generation with coal, because the CO2 concentration is so much higher, it's actually much cheaper to capture the CO2 off of coal and put it into the ground. So your net CO2 results is burning coal is lower than it is burning all the gas down in the Cook Inlet area. Of course, that'll never happen, but it's just an irony of the analysis that we're doing.
Yeah.
And I look at a potential customer for the CO2 to tell you that they currently send, was it 40 railroad cars a year to Baton Rouge, Louisiana, back and forth. You know what I'm talking about there, Howard. Back and forth to meet the needs for the state. And they say, wait a minute, you're telling us, you're right, they really like to see this happen because we would have the product right here. Think of all the savings they would have not sending 40 railroad cars back and forth to Louisiana year round.
And they gave us their daily use of CO2 in the state, and one of our Jan-Bacher engines running 24 hours a day on natural gas is a perfect fit for their market. Perfect fit for their market. So that's just on top of. And then one final thought, because if we get to the coal piece with Golden Valley's announcement that they're going to shut down Healy 2, right? If we can find clean uses for that coal that would really help the Healy area, this power plant is one of them. And then the other side of this is we just made passing reference to the pyrolysis liquids and oils that are generated off there. And we're hoping to sell that as an asphalt binder. But recently, the Department of Energy has provided us at UAF with quite an incentive to look at other non-fuel beneficial uses of coal tars and pitches, including coal foam for manufacturing and a number of other things. And all of that starts with those pyrolysis liquids. So as I was saying to these guys, I mean, we're here talking about a coal gasification project, but to these other potential manufacturers, it's a coal liquefaction plant, right? Because they want to use the liquids as an input for value added, and we desperately need manufacturing in interior. So this is a terrific feedstock, and unless you think that these coal oils and tars aren't used for anything, Kodak film used to be made from them. Pharmaceuticals are made from Tylenol. A big input of Tylenol is residual from coal liquefaction and oil. So there's a lot of uses for these things. We're looking at things that make sense in Alaska, like we're looking at making construction materials out of that. We're just spinning up a whole new team right now to look at that.
Yeah, and I think to Brent's point, on the carbon foam, or basically coal foam, there's a commercial scale DOE funded plant in West Virginia, I believe, that just came online. So and later on, we'll discuss that, but you know, that's another low hanging fruit if we can bring this project across the finish line to create opportunity for manufacturing that would improve resiliency and lower costs. So it's win-win all around.
Well, everybody, this has been a very interesting and informative presentation. So thank you so much. For the good of the order, and actually maybe to kind of balance the discussion a little bit for some of our other members, I have been working to try to get Alaska Renewables as our presenter. They were just on KUAC, actually twice in the last 2 months, relative to large scale wind projects they're proposing, one for here in the interior, one for closer to Cook Inlet. And again, I've been they're tentatively scheduled for next Tuesday. I'm trying to work out whether or not we can pull that off, but just know that that is coming. Well, guys, again, thank you very much. Please, Mr. Mayor.
Tonight at my city hall, in my newly reinvented chambers, we are going to have a presentation that's non-technical for my community, for my constituents at 7 o'clock. My council should meet at 6:30. So David's going to present there so that the community can understand what we're trying to bring there. And overall, my wastewater treatment and water treatment plant are huge users. And I'm looking right now where I could save $360,000 a year by not having all my boilers on oil. That 360,000 into 1,000 tax holders, you know, that's $360 more a year in their back pocket. I hope they would think that's worth it. But we never will know how much more it can be. Because none of us can prophesize where all this volatility is in fuel right now. So I will put that plug in. So it'll be a more easily understandable for the common person to hear what David's going to present to them tonight. So anybody listening want to come, just please come. We even have door prizes. Yeah.
Bag of coal.
I'll have to recommend that.
Oh,
to
good,
you, Mayor.
yeah.
All right, well, everybody, again, thank you all so much for the guests. Thank you so much for the audience for attending. And again, just look for your emails to see what I've been able to, or am able to nail down for our next meeting. All right, thanks a million, everybody. Have a great rest of your week and great weekend.